Hi everyone, my name is Karthik. My matrix number is B0919100083. I am from BMMH year 3. Today I would like to present about my final year project based on the title of Effect of Temperature to the Electrospinning PBA Nanofibers Structure. I am under supervisor TS Dr. Amir Abdullah bin Muhammad Damanhuri. Nanofiber membranes are common in air filtration industry these days. So to produce a nanofiber, there are some ways, and one of the best ways are by electrospinning. In electrospinning, there are drawing, self-assembly, template synthesis, phase separation, and lastly, electrospinning are some of the techniques that can make to use nanofiber. So electrospinning is a fiber production method that uses electric force to draw charged thread of polymer solution or polymer maps up to fiber diameter in the order of some 100 nanometers. In this study, I used polyvinyl alcohol, PVA. So PVA is a water-soluble synthetic polymer. As you can see in the picture, this is a simple drawing of a electrospinning process, and on top of that, it's a nanofiber cloth. So importance of electrospinning. The importance of electrospinning techniques are for the production of very thin fiber to the order of few nanometers, which large surface area with various purposes. For an example, this electrospinning method used to create a filter such as HEPA filter in the HVAC industry. And these are some type of defects that may appear when we are doing electrospinning, which are beading, bundles, bonding, and multiple defects. So what is polyvinyl alcohol? Polyvinyl alcohol was chosen as the solution because it is a water-soluble synthetic polymer. PVA has an excellent chemical properties with a semi-crystalline and heat-stable hydrophilic polymer. It is odorless, non-toxic, and resistant to oils and grease, and it is often used in filtering the air. Its unique physical properties such as strength, flexibility, and ability to function in a high oxygen environment, and this is the best choice for this case. So the problem statement in my study is determination of temperature that contribute to the effectiveness of average fiber diameter. The second one is determination of tensile strength of different nanofiber sample based on outcome from the different temperature. Objective of my studies are to investigate the average fiber diameter morphology of nanofiber membranes based on the different temperature. To study tensile strength of nanofibers based on different temperature. There are some scope of researches in my study. The first one is to use the constant polymer concentration, namely 10% of the concentration. To use of constant power supply voltage of 15 kilowatt for the electrospinning process. Use of 15 centimeters distance between the tip and the pipette to the collector plate. Use the feed rate between 1.5 milliliter for the solution released from the syringe. Use of 30 degrees to 50 degrees temperature for the electrospinning process. The discussion for this research morphology structure was analyzed using scanning electron microscope, SEM. The final one is to find out the tensile strength of PVA nanofibers. So there are 4 parameters that I kept constant based on previous studies, which are concentration, power supply, distance, and feed rate. So these are my methodology process. So here I use this sample preparation, which I use the concentration formula. And these are the process when I am mixing the PVA solution. And these are my flowchart based on my studies. I started with pilot studies and I continue it with literature review. and I buy things for this experiment, which is set up, and I prepare the sample, which is the PVA solution, and I continue it with electrospinning. Then I divided the observation based on scanning electron microscope SEM and the tensile strength test. And finally, I continue it with result and discussion. So these are during the electrospinning process. So in this study, I use this machine, which is Electrospins EZIA model in factory 2 in FTK. So the second picture shows the process during the electrospinning, and these are the result when after electrospin. This is the scanning electron microscope SEM. So as you can see at the first picture, this is the sample before coating with platinum. And the second picture is showing sample after coating. And the third is the results. These are the expected result which can occur when I'm using scanning electron microscope. So as you can see, there are some fractures, bundles, and beading when we are using microscope to see the morphology of the fiber, average fiber diameter. So as you can see, pore size decreases as ambient temperature increases to certain pressure, which means the pore sizes are smaller when there are greater temperature. So when we use higher temperature to do the electrospinning, there are more quality nanofiber material to be produced. And these are the second test, which is tensile test. Here is sample machine which used for the tensile test. These are the placement, and the white color is the nanofiber material. And these are the expected result, and graph would be shown in my study. So the conclusion for my study case is the validation data shows that the fiber has a morphological structure suitable to air filtration application. So the water-soluble and hydrophilic nature of PVA makes it suitable for use in fluid filtration application, while the hydrophobic category for air filtration. So when we are using PVA nanofibers, we can use it for air and water based on our needs. So that's it from me. Thank you.